Great. Hello, everybody. Welcome to the Stella Dev Camp. We are very, very excited to have you all here. My name is Laender, and I am currently contributing to Hardal as Head of Business Development. And so today, this month of March, we will be having the Stella Dev Camp, which basically involves and includes our builders coming on together, building, learning about Stella. And if you have experience with Rust, this is a perfect opportunity for you. So we have a very, I'm very excited about our tutor today. He's called Ayomide. Ayomide is gonna introduce himself, but just to give you an overview of what to expect and what to actually look forward to. So what I'm presenting right now is the Stella Dev Camp landing page. So we will be updating all the information on here, including all the recordings. For instance, today's virtual technical workshop is going to be about fundamentals. And so we will be updating the presentation links and the video links and any other necessary information that you'll be needing for you to be able to complete yours. To complete the Dev Camp successfully. So we also have the calendar of events here. So you would want to check it out. It has all the information that you will need. And most importantly, we have the agenda. Maybe some of you are wondering, so what is the agenda? Where is the agenda? What do we expect? What do we know about what's coming up? So all that information is actually on this landing page, on this Notion page, and you can just have a look, have a quick scan through and see what to expect for each and every week. So the way we are scheduling this cohort is in the sense that this first week, you're going to obviously learn about the fundamentals up to day 5. And then of course, we will have some assignments, but Ayo will share more information about it. And then you will have like advanced concepts to learn about smart contracts, and then now get to introduce you to open source contribution through Only Dust. So in case you are in Nairobi in Kenya, you are lucky because we will have an IRL meetup, and where we will now award all the successful developers and successful builders with certificates of completion. And we'll also just want to now understand what you've been building. So we'll have like a mini pitch competition. And of course, we will give you all some awards on that day. We will share more information about even the award, what it will be like and what it will be about. So that is just an overview of what to expect in a nutshell. So I'm really, really excited that this is our second cohort. We've completed our first cohort with Stacknet, and so the Stella one is our second cohort, and it's really, really exciting to have this cohort under the Hardal Dev Camp. So Ayomide, I don't know if you can talk and if you can share your screen, please confirm to me and we could get started.
Yeah, I can talk and I can share my screen.
Fantastic.
Okay.
We would also love to see you. If you can turn on your camera, that would be amazing.
Okay, give me a second. Let me set up my webcam.
Okay. All right. Cool. Great. So also, as Ayo is getting ready, we will really, really appreciate you guys to actively participate, ask questions. I hope you all are in the Telegram chat. Feel free to just ping us. I'm almost always posting on there, so you won't miss me. But yes, in case you have any questions and concern, feel free to ask. We are happy to answer all your questions. But most importantly, we would love for each one of you participating in this cohort to be part of the Hardal Dev Camp GitHub. So that is the dedicated place where all the projects that you are building will be hosted. And even for the upcoming hackathon, it will be easy for us to now filter out who are actually the kind of builders that would want to give scholarship to, because that's another exciting opportunity that we are giving out as Hardal, and that will be number one criteria that you will use to give out any particular scholarship. We'll have to double check, see if you're part of the Dev Camp GitHub, and then now see what projects you've been building, and then now you could get a chance to win some.
Okay, so I was told I cannot share my screen because the host doesn't allow that.
Oh, sorry. 1 minute. Just 1 sec. You know what? I'll just make you co-host. So it's easy. All right. Let me know if you can share.
Okay, I suppose you can see my face now, right?
Yeah.
Okay. Hi everyone. I'm happy to have everyone here. Ayomide is my name, and I'm a blockchain engineer. I write smart contracts on both EVM and non-EVM blockchains. When I say non-EVM, that includes Stella, writing Soroban smart contract. And that's basically what we would be focusing on today, talking about the Stella ecosystem and all of that. But without wasting much of our time, I'm going to share my screen and we're going to start from there. Okay. Just to confirm that everyone can see my screen. Can everyone see my screen? Okay, great. Okay, so Ayomide is my name, and I have experience lecturing when it comes to the blockchain ecosystem. I have handled a cohort previously for the Stellar blockchain, and in fact, one is currently going on as we speak. But what we have here today, I would like to highlight some of what would help every one of us have gained maximum knowledge from what will be going on in this cohort. I think there's a hand raised. Do you have something to say? Okay. So one thing that would help every single one of us to have maximum gain from whatever would be going on from this class would be asking questions. One of the important things when it comes to learning is asking questions. For those who have been my students from previous cohorts, they understand how important question is for me. And that's important. That's exactly why I ensure that when every single person is having difficulty understanding something, I do not mind going back to slide one, and I do not mind explaining it all over. Although we have a constraint time for everything we will be learning, but notwithstanding, I will try my best to ensure that every single participant have a deep understanding as to what we'll be learning. So just to be clear, Esther, how do the participants ask questions? Are they meant to unmute their speaker, or what's the process for that, please?
Yeah, they could actually use the chat. They can just type in the chat. But also, if someone wants, like, prefers to talk, then you can give them their mic so they can talk. And then another thing, if it's possible for you to just put it in a presentation slide so it's actually bigger enough, that will be really good.
Okay.
Yeah, fantastic.
Okay. So welcome everyone once more. What are the things we would be learning at this class? For today and tomorrow, here is an overview of what we'll be talking about. Esther shared the Notion page, and you can go there also to get more information about this. But here's an overview of the topic we'll be going through for today. We'll have introduction to Stella and Soroban. We will understand what Stella itself is and what relation does Soroban have with Stella. Are they the same thing? This is what we'll be enjoying from today's class. Next up, we'll be setting up the development environment. We will then be understanding Stella's asset model and accounts. We'll understand what private key, public key is. Then we would have a comprehensive introduction to Rust. Then we would be writing and deploying a very simple Soroban contract. So this would be more like an overview of the introduction to what we'll be talking about in this class. So starting up, what is Stella? Stella is literally a decentralized blockchain network for fast, low-cost transactions. Now, based on the fact that every single person I want to assume on this call has probably gone through previous cohorts, I would not want to use that as a basis to explaining what a blockchain is. Now, in a simple sense, a blockchain is a decentralized network that allows for transparency. And how does it do this? It does this through a mechanism called consensus network. So a blockchain, literally, you can think of a database, and then you can think of this database in a distributed manner, connecting to each other, and then each of these database is in sync with the same data. You can think of a blockchain like that. But then what makes all of this data the same thing? What ensures that this particular database in this geographical location is not having a different data from what is in a different location? What's making everything come together and sync? It is what we call decentralization, consensus mechanism, I mean. It's literally what allows all of this data in different locations come to sync. Now, Stella makes use of a particular type of consensus mechanism. It's called the federated Byzantine consensus mechanism. And in this particular situation, that consensus mechanism literally allows it to use what we call quorum to come in agreement for decentralization. So what then are the key features of Stella? What makes Stella different from other blockchain? One of the beautiful things about Stella is that it has a feature of cross-border payment. What do I mean by cross-border payments? Now, using Stella, it is now very possible for you to create an application that would allow you to send fiat from one country to another using the Stella blockchain as the intermediary. And when we talk about blockchain, we understand transparency. And this is one of the beautiful features of Stella. And using different anchors, it's possible for you to build your own cross-border payment platform with Stella. Another thing is it allows for multi-currency support, whereby you can build a platform that has different currencies. So it's not just one currency from one country to another. You can basically build different currency support. Also, decentralized exchange. Now, decentralized exchange will definitely not be a new concept or a new word to many of us, but this is also one of the beautiful things about Stella. Now, what then are other beautiful things about Stella? Other beautiful things you can think of Stella is the ability to do something. Where exactly is that? That takes us to the next slide, Soroban. With Stella, it's possible for you to think of any implementation, write the smart contracts, and then deploy on the Stella chain. What do I mean by everything I've just spoken about? Now, from the previous slide, I was saying it's possible to have cross-border payment with Stella using different anchors that is being provided. Now, we are moving a step further, talking about what if we want to build something else? What if we want to think of a different thing that has nothing to do with payments, nothing to do with fiat, nothing to do with cryptocurrencies? Stella allows for that. So you can sit down and think, there's a problem in my area whereby the different hospitals don't have sync when it comes to patients' record. Is it possible for me to solve this solution using Stella? Is it possible for me to, create a solution that would allow me to build a program where different hospitals in my area can basically enjoy transparency when it comes to patients' data, whereby patients come to this hospital today, because that hospital already have the data available through a platform I have built from another hospital. It's easy for you to just diagnose that patient and just go through with the patient's previous record. And it's possible for you to just give the patient the treatment it needs. Now, that is a different idea I've just spoken of. Would I use that particular idea with cross-border payments? Does that have anything to do with multi-currency support? The answer to that is no. What allows for this is Soroban. So Soroban is literally a smart contract platform on Stella that allows you to think of any implementation, and all of this implementation, you are able to build it on Stella. Now, let's take our minds back to Ethereum. Let's take our mind back to Bitcoin. Now, at the very beginning, when Bitcoin was introduced, the only thing Bitcoin was known for was for it to do what? To send a transaction that includes sending cryptocurrency from one point to another. Now, it evolved up to a point whereby something needed to be done, in the sense that this is a decentralized system. This is a transparent system. Can we add an execution layer to it? And at that very particular point, Ethereum introduced execution layer, which allows not just only transfer of the native token, which is Ether on Ethereum, but also includes an execution layer, which allows for the deployment of smart contracts. So deployment of smart contract literally allows you to think of any implementation and then you deploy it. Now, when I made mention of Ethereum, you think of Solidity for their smart contract. But here in Stella, for the smart contract, what you think of is Soroban. Now, what's the beautiful thing about Soroban? Soroban is literally having some particular key features that makes it completely different from other blockchains. What are those key features? Number one, Soroban is literally built with Rust. So that means that if you are a Rust developer who have previous knowledge on Rust, it is so easy for you to now learn how to build and deploy smart contracts on Soroban. Now, what's the beautiful thing about using Rust? Now, for those with the knowledge of Rust, previous knowledge of Rust, or those without any knowledge on Rust, Rust is a language that allows for very fast deployment. Now, it makes use of certain mechanisms that allows for safe and fast executions. What are those things? We are going to, as we move further in this slide, we are definitely going to see some of those implementations or those mechanisms that allows us to say Rust is a very great language. Now, one of the key features on this slide, as you can see, is WebAssembly. Now, when you write your Soroban smart contract, it is compiled down. And now when it is compiled down to what? To WebAssembly. Now, this WebAssembly, it is compiled down to, the WebAssembly is then deployed to the Stella ledger. And when it is deployed from there, you can then instantiate a new smart contract. What's the beautiful thing about assembly? It's very fast. And now, when you think of assembly, we spoke about Rust. Now, Rust is not the only language you can use to write a smart contract and compile it down to WebAssembly. Now, you can use other languages, true, to compile down to WebAssembly. But Rust is the recommended one, as the Soroban itself basically supports Rust. So what we'll basically be focusing on at the course of this lecture is basically Rust. Another thing or another feature of Rust is that it's scalable and it's secure. What do we mean by scalable and secure? It's easy for you to build your smart contract in a very big way. What do I mean by that? Now, you can think of any idea. When I say any idea, and then implement this idea with your smart contract. Now, when you implement this idea with your smart contract, it is secure. Why? Because of the different mechanisms that is connected when it comes to deploying your smart contract and interacting with your smart contract. Another thing is it is developer friendly. And when I say this, you would agree with me that there are so many chains, so many programming languages that you would rarely find documentations to write that language. Now, for Soroban, it's quite different. Why? This is because Stella itself gives opportunity for every single person, every single individual, every single developer who is willing to, to go through the process of learning how to write Soroban to basically have access to it. In fact, if you join the Stella ecosystem, the Discord, you will definitely see some classes that is being taken. Also, another is the one I made mention of that I even take. All of that is all sponsored by Stella. So this is a place where you definitely have support to everything you are writing. So at this point, before I proceed on to the next part of the slide, why use Soroban? I'd like to ask if there are any questions from anybody at this point. Are there any questions? Okay. Okay, Benjamin. I think Benjamin raised his hand. You can unmute and speak, please, Benjamin. Okay, you can speak.
Okay, yeah. So, please, you've spoken a lot about the Rust Soroban. Personally, I'm new to it, so I am sort of like still finding my feet. But I want to ask that with all these, should I say, languages, right? It's sort of, so they are all networks, right? That we can easily build on it using like Stella, if I get your initial, your intro right. I don't know.
Okay. So just to be clear about your question is for the Soroban smart contract, is it different from Rust, or is that where your question is tilting towards? Yeah, you can unmute.
Yes, so that is where my question is geared towards. Yeah.
Okay, great. So here's the answer to your question. Rust is a language on its own. Now, Soroban is a framework built with Rust. So now, if you are familiar with React is the combination of JavaScript, HTML, and CSS. So it's a framework built around JavaScript, or if you want to use the other companion, TypeScript. So you can think of it like that. So basically, you can write smart contracts using Soroban, whereby all the syntax you are writing is basically Rust. So that's what I'm trying to say. Now, don't get confused. Don't worry at all. All of the things I'm doing is basically introduction. We are definitely going to write the smart contract. We are going to see what the smart contract looks like. And in fact, before we do that, we are in fact also going to talk about Rust itself. We're going to start to look at the basics of Rust. So there's no need for you to worry about that. So does that answer your question?
Okay. Yeah, thank you.
Great. Is there any other person that has question? Okay, now I'm going to the chat. Someone said, so Soroban is like another version of Solidity, if I'm correct. You are correct. So now, Solidity is a smart contract that is written and deployed on EVM compatible chains. Now, when I say EVM compatible chains, you can now start thinking of Ethereum, Avalanche, think of Polygon, think of Base, Sepolia is a testnet, think of it too. All of these are literally chains that allows you to deploy a smart contract like Solidity. And Solidity is compiled down to bytecode, which is then executed on the EVM as opcodes. Now, that, in a sense, is what we are going to talk about when it comes to Soroban. So Soroban is a smart contract like Solidity, and then that smart contract is what we deploy, but then just like you deploy, you write your smart contract Solidity and you compile it to bytecode. In our case, we write our smart contract Soroban, and then we would compile it down to WASM. So WASM is what we would then deploy to the Stella network. That's the Stella ledger. And after deploying the WASM to the Stella network, then we would create instance of our contract, and then we can start interacting with our contract. So someone is also asking, is Soroban something close to EVM's remix? No, no. EVM's remix is just the IDE. It's more like an IDE where you write your Solidity smart contract. Now, Soroban itself is a smart contract. You can compare Soroban to Solidity, not remix. Okay. Another question is, isn't Solidity compared to Rust in this context since they are all languages? Now, Solidity is a language built specifically for the EVM chain, while on the other hand, the Soroban smart contract is written with Rust. So what that means is that the language, the syntax, everything that is written in Soroban is Rust. So it's more like a language, a framework of Rust. Someone else asked another question. He said, say that again, please, how the code is compiled to WASM. Now, this is not a problem. This is not a problem. When we start writing this Soroban smart contract itself, then you would see how the code is then compiled down to WASM. So I hope that answered the question for every single person here. So with that, we would be going back to our slide. Why use Soroban? What are the benefits? Seamless integration with Stella's payment network. Yes. Now we've made mention of the anchor that allows for cross-border payment and all of that. If you build a smart contract, now that smart contract has a different functionality. Now the different functionality the smart contract has, you now implement this cross-border payment that allows people from different locations to now interact with this smart contract and then pay with their local currency. How beautiful would that be? That is one benefit of the Soroban. So you can think of the idea, build it, link it up, integrate it with one of the anchors, and then it's easy for payment in fiat in different local currencies. Another one is low transaction cost. The transaction cost compared to chains like Ethereum is very low. So there is a low transaction cost when you send a transaction to the Stella network. It's very low compared to other chains, other L1 chains. Another thing is high throughput. It's very fast. It's very fast when you send transaction. Comparison, how Soroban differs from Ethereum and other smart contract platforms. Yes, that's one thing we're going to talk about. So if you think of other smart contracts, now the only one I've made mention of on this call is Solidity. Now there are a whole long list of other smart contracts on other chains. Now you can think of smart contract like Ink. Ink is deployed on Polkadot ecosystem. That's the Polkadot blockchain. When you talk of the relay chain and the other connected chains to it, Ink is deployed there. Then CosWASM. CosWASM is the smart contract on this other chain, Cosmos. It's another type of smart contract. Now, another one is Concordium smart contract. Concordium smart contract is deployed on Concordium. Now, you can think of so many smart contracts for different chains. How exactly does Soroban compare to it? Or what makes Soroban more interesting than all of these other chains. The beautiful thing about it is that Soroban compiles down to WASM assembly. Now, the truth is that other chains like Polkadot, where ink is being used, the smart contract written for it is also a framework of Rust. Other chains like Concordium is also a framework of Rust. But then the interesting and beautiful thing about Soroban is that you can basically compile it down to WebAssembly, deploy your WebAssembly, and create instances. Now, other chains that applies to that uses Rust as for the framework also could do that. But in Soroban, it's faster and better. Setting up the development environment. So now you can think of the development environment as your farm. Imagine you are ready to plant cassava on your farm. You definitely would not walk into the land and not do anything, or just start throwing your seed or whatever you need to plant it. You definitely have to clear the land, prepare it, till the soil, also, make heaps for the different planting you would be doing. And so the same thing is required for you to write your Soroban smart contract. Now, for this particular use, setting up, one of the beautiful things I like doing is I like showing my students how to use the documentation themselves. Using the documentation will do something. It will help you understand how important it is for you as a developer to always refer to the documentation. As a developer, the documentation is your friend. You always and always want to refer to the documentation for you to do anything you want to do. And so for that reason, I'm going to go straight to the Stella documentation. And yes. So it's just as simple as you can see me typing it. The Stella documentation, you can click on it and set up. So I'm going to increase this for everyone to see it. So now, while I have all of this in my slides for us to go through, I still love it when developers are being taught to always refer to the main documentation. This is because for every single problem you would have, the documentation is usually where you should go to. Now, one interesting or certain about the blockchain is that there are so many hackers out there, and one of the things they do is for them to install payloads on your local machine. Now, that's why it's important that you don't run any command that's not coming from the official documentation. So you do not install a payload that could hack your system where you are getting from probably a slide or anywhere. No, it's important that you often go to the documentation for this. So what are the tools we would need for our development environment? First, we would need the Soroban CLI. The Soroban CLI is what will give us access to everything that has to do with the Soroban. That's the host and every other interface, all the methods we would need from Stella for Soroban. Everything is inside the Soroban CLI. Another thing we'll be needing is the Rust compiler. Now, for us to have the Rust compiler, that means we definitely have to install Rust on our system. So that means we would install Rust and then also install the compiler together. Then another thing is WebAssembly targets. You have to prepare your system for the Soroban development. So let's go to the documentation. For the documentation, as I've made mention of, the Stella smart contract are programs that are written in the Rust programming language. So to develop it, you definitely need the Rust toolchain and an editor that supports Rust. Now, when you talk about editors, I actually love VS Code editor because it literally allows me to write different languages and I can just, get to write it without having to think of so many installations and all of that. So I prefer using the VS Code. Now, another thing you need to do is to install the Stella CLI. So the Stella CLI, like I made mention of, is what will give you access to everything you need to install Stella. So to install Rust, I'm going to drop this on the chat. So let me drop this on the chat. Okay. Now, okay, I think I didn't drop that to everyone. Let me switch it to everyone so everyone can get it. So that's the link to the official Rust Stella documentation where you can basically install all of this. Now, the beautiful thing about it is that I have installed all of this before on my system, and I would not want to reinstall it again on my system. So like I made mention of, the first thing to do is to install this. So all you have to do is to open your terminal and create a new window. And then when you create a new window, you copy this, you paste it there, so it installs Rustop. Now, after it installs Rustop, the next thing for you is to then install the WASM target. So after you've done that, the next thing for you then is to install the Stella CLI. The Stella CLI, like I made mention of, is what gives you access to all the features on Stella. So you can think of it like a sandbox that allows you to execute your smart contract, whether on the future net, the test net, or the main net. So now, talking about the future net, the test net, and the main net. Now, for those that have attended my usual class, I have explained this very well, but I'm going to do a quick explanation of this right now. So now the mainnet is the main blockchain for Stellar where real life asset is being done. So when you can think of it as going into production, the mainnet is where you have your smart contracts deployed to. What of the testnet? The testnet is a test environment whereby you want to quickly write a smart contract. It's easy for you to just write it on the testnet and then deploy it to the testnet for you to test if your smart contract is fine. Remember, for you to send any transaction to the chain, you need to pay for gas fee. And for this reason, it's important that you use a testnet because you could deploy just one smart contract more than 5 times during development, because while you are developing, you deployed. Oh, you thought a particular functionality is not needed. Then you add the functionality, then you deploy again, you test, you go through the whole process on and on and on and on like that. So doing that literally gives you the opportunity to not waste real assets, which is Lumen, XLM, for you on the mainnet. So it's easy for you to just get a faucet on the testnet. I haven't explained FutureNet, but I can see a hands up. Okay. There are 2 hands up. I would allow you to unmute. Okay. So, yeah, Tosin, let's
Yeah,
hear
so
Tosin, please.
yes, please, Benjamin here. So I want to find out, I was like I'm using the Windows
Yes,
subsystem like
I'm also
Linux.
going to Windows. I noticed I'm talking about Mac and Linux first. Yes, I'm definitely going to Windows. I'm definitely going to Windows. Don't worry about that.
Okay,
Tosin.
but then with Linux environments, yeah, so that I wouldn't want it to like directly be sitting on my PC. So I would want it possibly virtually. I don't know if that is also a good way of installing it.
No problem, no problem, no problem. So let's hear from you, Tosin. You can unmute now. Tosin, your hands are still up. Okay. I guess you didn't have any question. Okay. Okay. So we would proceed. Someone is talking about WLS users. Yes. Windows users, there's a section for you. Here's the section for you. Now, the installation of Rust for Windows is completely different from the installation of Rust for the Mac and Linux users. And that's exactly why I wanted to go through the installation for the Mac users and the Linux users before going to the installation of Windows. Now, the thing about this class is that we would not be covering every single part of it. Why? Because of our time constraints. Now, but one of the beautiful things that you would then enjoy from this class is I would ensure I touch all the parts from it. So the important thing for you is to always go back to continue to, look at the source, which is the documentation. So from there, you can basically, learn more. So this whole course would be covered for 1 month. And in the process of that 1 month, I would want to, add learning of, Rust, learning to write smart contracts into it. And trust me, if we sit down to talk about just installation, we might not complete everything we want to talk about. So that's why I'm trying my best, to try to bring everything together it gets. So having that in mind, we'll proceed to looking at the installation for Windows. So for Windows, you can also install it using the Rostop target add, this basically to install the target. But for you to install the Rostop itself, you basically have to, download this Rostop init execution file. Now, when you download this Rostop init execution file, you run it, and then while it's running, it's basically install every single thing you need to install in Rust. So the process for the Mac OS and Linux is quite different from Windows. So you have to go through this documentation. That's why I dropped the link for you to understand it. Now, like I made mention of, you could use different code editors. For me, I personally like using Visual Studio Code Editor, as it's literally the code editor I love the most when it comes to development. Now, you can use Rust Analyzer inside of your code editor, and then you can use Code LLDB for step-by-step debugging. So all of these are basically what you can use when it comes to the development. So yeah, also other things you have to go through for the installation. Now, when you're talking about the installation, there are certain things you have to think of. You have to think of how you would install what you would use for the deployment. Now, here is how you do that, basically. So here is the batch script you would copy for you to, to install that. Now, all of what I'm doing, don't worry about it. We would basically see it as we proceed. All of this is just an introduction to Rust, introduction to Soroban, and all of that. So coming back to our slide, I want to see if there are any questions. Okay, so there are no questions for now. But just to be sure, are there any questions for me? You can use the raise hand button before I proceed back to the slide. Okay, yeah. You can use the raise hand button if there are any questions. Okay. Okay. You can speak up, please.
Hi.
Hi.
I'm asking, you have said Soroban is first. Yes.
Yes.
So so my question is, if there's gas fees, and how do you how can you explain to us how it's fast, but yet it's having something like gas fees? Because I think there'll be some lag there.
Okay. Now, that's a very great question anyways. I appreciate that question. Now, when you think of the blockchain, now you can think of the blockchain as a world computer. What do I mean by world computer? That means that every single transaction that is being sent to the blockchain, all of this transaction has to be verified before it is added to the block. So this means that a particular transaction that is being added to the block, remember I said you can think of the blockchain like a database that is decentralized in different geographical locations. So that means that that transaction has to be verified. And the verification we are talking about is what? Is through what we call the consensus mechanism. Now, the people that are basically validating this transaction now on the Stella ecosystem, these ones are not incentivized. Rather, they are basically doing it to help the community, to help the network decentralize. These are not, although unlike other chains where the validators are incentivized, it's not happening. Now you can now think of a situation whereby a person writes a program in Rust that is in Soroban, and then the program has an infinite loop. What then happens to the whole chain? Does that mean that because that person ran an infinite loop, the whole chain would have to wait until the person's infinite loop is completed? No. For that very reason, gas is introduced. So gas fee basically calculates the how much you need for execution for a particular function you are calling, that is, you are interacting with, and then it basically charges you based on that. So a person cannot perform something like a DDoS attack on the network. And so for this reason, it's basically, although the truth is that you cannot compare the speed and deployment of a Soroban smart contract interaction with something like Visa. Now, the fact that it has to go through consensus mechanism, it has to go through validation, and in the consensus mechanism for Rust, there is what we call quorum, and the quorum has to go through what we call voting and all of that. Because of all of that, the truth is it is not as fast as Visa transaction, for example. But then, compared to other blockchains, it is also one of a very fast blockchain because it actually executes very fast. Does that answer your question, Matt? Hello, can everyone still hear me? Matt? Okay, great. Okay, great. So moving on, we've looked at how you can basically set up your Soroban CLI. You have to install Rust if you have not installed it. Now for Rust, you have to install Rust itself by going through this command, which, don't worry, like I made mention of, I would not advise anyone to use commands that are written in a slide. I would always encourage every single person to go to the official documentation of Rust for installation. Now, here is basically the command you would find for the official installation of Rust, but always use the official documentation. So also you then add the WASM targets, you verify it, then you verify if you have the right version and all of that. And then once you've verified all of this, you are basically good to go. Understanding Stella's asset model. Like other chains, Stella basically have the native assets. What is the native asset on Stella? It is Lumen, and it's basically XLM. So Lumen is the native asset on Stella, and Lumen, you basically use it to pay for gas fees, and also you use it, to send transactions. So imagine you are sending, if you are calling a function on your Soroban smart contract, you need Lumen to interact with that smart contract. You are deploying, you need Lumen. All of this is a native, the Lumen is basically the native asset on Stella. Now, you can compare Lumen to Ether on Ethereum, which is the native asset on Ethereum. Now, there are other custom assets on Stella, other assets that are deployed as Soroban itself. You can deploy a Soroban token contract that would be an asset, and it will be backed up with liquidity. These tokens could be issued by individual. You as an individual could basically, issue this token. It could also be issued by an organization. But another thing is it requires trust line for holding. Now, what exactly is trust line? All of this is what allows it to basically have a backing on the Stella network. Stella accounts. What is Stella accounts? Now, when we started, I made mention that one of the things we'll be talking about is the Stella account. And when you talk about the Stella account, what comes to you is key pairs. You have the public key and the private key. The public key and the private key is basically what you use to send a transaction. So now, for those that are new to the blockchain, when you want to send an asset to a person, what you ask for is the public key. The public key is basically what the person sends to you, and then you are able to send an asset to the person. What is the private key used for? The private key is basically used to initiate a transaction. So the private key is basically, you could call the private key an externally owned account, EOAs, that allows you to what? To send a transaction. What is sending a transaction? Now, there are different types of sending transactions. Now, you could send a transaction that's for deployment. You could send a transaction that's for invocation of smart contracts. You could send it for interaction. You could send a transaction that includes just sending Lumen. You could also send a transaction that calls for something else on the Stella network. But all of these transactions are paid in Lumen, which is basically XLM. And the truth is that it's actually a very low cost transaction. So at this point, I would want questions to troop in. Are there questions? Okay. Okay. Anyone with question? Okay, great, 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 great. Okay, so basically, our class for tomorrow would basically start with introduction to Rust. So during tomorrow's class, I expect every single person on this call to have installed Rust on your system, and also every single one. I think there is a message on the chat. Okay, so this person asked the question, can you build your own token on top of Lumens? Now, that question is a great question, but it is asked in the wrong form. The main question should be, can you build your own tokens? The answer to that is yes. So you can basically build your own token. You can think of USDC. USDC is a token. It's not a native token. It's a custom token that was built. You get? So you can also build something like that. And then when you build your own token, to deploy it, you need Lumen to deploy it. Also, to interact with it, that's to call the transfer function, you need Lumen. For you to probably, if it's a token that has a mint function, a public mint, you have to use Lumen to interact with it. And so basically, Lumen is the native token you use for all the interaction. Okay. So now, someone else asked, what wallet do we use to store our assets? Now, there are different wallets. Now, different people build different wallets, but one of the popular wallets is the Albedo wallet. It's a particular wallet that allows you to, store your assets, get your asset. Also, since it basically gives you access to private keys and public keys, you can basically also use this wallet to send a transaction. So I personally use the Albedo wallet, basically. Any more questions? Okay, if there are no questions, here are the overview of what we'll be discussing tomorrow. We'll be starting with the introduction to Rust. We will then be seeing the basics of Rust, variables in Rust, up to the point where we talk about functions in Rust, understanding a mechanism in Rust called ownership and borrowing. Then we'll move on to talking about enums and structs in Rust, even moving on to pattern matching, where we'd learn how to use the match keyword, error handling, testing, and then if there is time tomorrow, we would also write a simple Soroban contract, but I doubt that because all of these things we are seeing here would basically be implementing them with code by tomorrow. So at this point, thank you very much, everyone. I would stop sharing my screen now. And Esther, are you there? Okay. Hi, Esther. Are you there? Yes. Yes. So someone asked, what time is tomorrow's class? Tomorrow's class is basically the same time as today's class. Then another thing is, yes, the notes will be shared. I would send the note and it will be shared with you for you to go through it. Now, one thing I made mention of earlier is that this whole thing we'll be going through everything in 1 month. Now, you will notice that I was talking a little fast because if you've gone through my previous classes, I try to break everything to the lowest point. But because of the time constraints we have, it is important that every single thing that is done in class is prepared and practiced every single time after the class. So this means that everything we've discussed today, starting from the introduction to the installation, it's important that you practice it after the class. So by tomorrow, you are already ready for us to have the interaction with Rust itself, start writing basic instructions in Rust. So thank you very much, everyone. Okay, okay. UJ, you made mention to to unmute you. Okay, let me look for you. Can you raise your hand? Okay, I found you. Okay, so you could speak, please.
Yeah. Hi, everyone. So, yes, I would want to, I'll be the one co-hosting with Esther for this cohort. Nice to see you, Ayo. I'm also a Web3 Bridge alumni. It's nice to have you here. So, someone asked a question, Moses. Yes, we have a community and we have a Telegram for this. Yeah. So the end goal is to, after we're done with Stella, you guys should be able to build products, and we are hoping to have you at the residency. We'll be having a residency after having all these cohorts done monthly. And then we expect you to build awesome projects in Stella. Stella, they have grants. And yeah, so Rust is a pretty steep learning curve, and I understand it. So if you guys, someone said if you want to get started in Rust, you start with Soroban. So you guys are on the right track. If you guys know Rust, that's even better. So yeah, Hardal made this possible, and we are hoping to have you create impactful products at the end of this. I thought the lessons were supposed to be 2 hours. Just to counter check on that.
Oh no, it's meant to be 1.
It's 1 hour. Okay, nice. I hope everyone has been able to like install the Rust so that tomorrow we can be like, go get forward, keep moving. And I don't know why I couldn't be able to like unmute or like show my face. Maybe we'll figure that out tomorrow with the settings, maybe. Yeah, classes are every day, Monday to Friday. Hopefully we'll have different like IRLs in between, or maybe one IRL after the whole month, both in Nairobi and Kisumu, hopefully, so that you guys can meet